The Huggable, a new type of robotic companion for healthcare, education, and social communication. The Huggable project was started in January of 2005 with its original inspiration from companion animal therapy in the somatosensory system of humans and animals. The Huggable is being designed with a full-body, multimodal, sensitive skin, with over 1,500 sensors all over the surface of the robot. Underneath the plush fur exterior of the robot is a layer of soft silicone rubber above this sensory system. Quiet mechanical drive systems with 3 degrees of freedom in the head, 2 in each arm, and a combined eyebrow-ear mechanism for expression. A 6-axis inertial measurement unit for gesture input. Cameras in the eyes, 1 color and 1 black and white. Microphones in the ears, a speaker in the mouth, and an embedded PC with 802.11g wireless networking for data collection and communication. The Huggable project consists of both the Huggable robot and a set of simpler, easily deployable technologies which apply a subset of functions of the main Huggable robot to a unique, targeted application. Additionally, the Huggable robot has 2 modes of function, as either a fully autonomous robot where the Huggable is interpreting and responding to human interaction, or it can function as a semi-autonomous robot avatar with some level of human control via the internet. In this video, we will demonstrate some of the functions of the Huggable as a semi-autonomous robot avatar for social communication and education. In the social communication setting, the Huggable can be used between 2 family members. Here, the Huggable robot would be placed in front of a grandchild and controlled remotely by a grandparent or parent via a website. Through this system, the parent or grandparent can see the child's face through the eyes of the Huggable, hear their child's voice through the ears of the Huggable, and interact and play together through the Huggable robot avatar. Such a system could also be repeated for education. In specified instances such as language learning, a remote teacher can not only interact with the student through the Huggable via a website, but can also monitor and teach a lesson using the child's own home or school computer in tandem with the Huggable robot. Here, we show a screenshot of the Huggable website. In the upper left-hand corner is a live video feed from the Huggable's eye camera. The lower left-hand corner is a real-time simulation of the Huggable robot. On the right are a series of push buttons for animations and sounds which can be played back in real time on the Huggable robot. Finally, in the bottom of the right side of the website is a cartoon depiction of the Huggable, which indicates how the child is interacting with the robot, such as if they are picking the robot up or bouncing it up and down. Now we will demonstrate how the Huggable can be controlled remotely via a joystick on the parent or teacher's computer. The Huggable's head can move left and right, as well as up and down via this interface. One thing to note is that as the Huggable moves its head, the virtual Huggable and the camera view on the website provide a clear indication of where the Huggable is currently looking. In this next video, we will demonstrate one of the autonomous capabilities of the Huggable robot, the ability to look at people's faces without external control. As shown in the Huggable eye camera viewer, when the Huggable sees a person's face, it places a red box around that face. The Huggable then uses this information to keep that person's face directly in the center of its field of view. Such a system can help the human operator by allowing them to focus their time on the interaction and not with keeping the Huggable constantly looking at the person. Here, we demonstrate another feature of the huggable system, the ability to quickly and easily select which person the huggable will look at via labeling. Here, the huggable is currently looking at Alan. Using the website, the current location of Alan's face is marked and labeled, and a push button for Alan is created. Next, using the joystick control, the huggable is turned to face the next person, in this case, Dan. Once the huggable is looking at this new face, the name of this new person is marked and labeled, and a push button for Dan is created. Now, at the push of a button, the huggable can turn its head back to Alan and back to Dan. As shown in the video, the marked positions provide a rough location of the person's face, and the autonomous look-at behavior autocorrects to keep the huggable looking directly at that person. Such a system has much benefit in the case of a parent interacting with more than one child, or a teacher trying to teach a group of students via the huggable robot avatar. By reducing the cognitive load of controlling the huggable robot with a joystick to constantly move back and forth among people, this interface opens the door to much more engaging interactions. The website interface to the huggable robot avatar allows sounds to be played back in real time on the robot at the click of a button to enhance the interaction. The inertial measurement unit inside the huggable robot is used to measure the current orientation of the robot. This information is then displayed on the website to allow the operator to have an idea of how the child is holding the robot and thus can incorporate this information into the interaction. Additionally, the live camera feed from the huggable's eye camera is offset by this rotation, which helps to keep the operator from getting seasick, and it helps to keep the face detector algorithm working even when the robot is on its back or its side, as shown in the video. The inertial measurement unit is also used to detect specific gestures, and this information is displayed on the website via the animated huggable graphic. These gestures include conveying if the huggable is picked up, bounced up and down, or rocked back and forth on its back. Finally, a set of passive potentiometers in the hips and ankles of the huggable robot is used to detect if the child is playing with the feet of the robot. This information is displayed on the website and can be incorporated into the interaction. The huggable is being designed with a full-body sensitive skin with over 1,500 sensors. The size of each force sensor has been chosen to be roughly the size of a human fingertip, as much of the focus of tactile interaction will be with human contact. The design of the huggable's sensitive skin is inspired by the design of the somatosensory system of humans and animals. Thus, it features the four modalities of somatic sensing: temperature, touch, proprioception, and pain. Here we show a section of the arm of the huggable, which features 64 force, 24 temperature, and 2 electric field sensors. The white squares are the QTC force sensors, the silver sensors are temperature sensors, and electric field sensing is done using electrodes embedded in the circuit boards. The feel of the huggable is also important. To help provide a soft, lifelike feel, a layer of silicone rubber is placed underneath the fur exterior of the huggable and above the sensitive skin electronics, as shown in the photo. Here we demonstrate the response of the electric field sensors to human contact. The electric field sensors allow us to detect proximity information and very light touch, such as gentle stroking. Additionally, these sensors are tuned to distinguish between touch from an object, such as this plastic rod, and touch by a person. Thus, the huggable is being designed to distinguish if it is sitting on a tabletop or sitting in someone's lap. The response of the electric field sensors can be combined with the response of the force and temperature sensors to determine the type of tactile interaction. We are currently developing algorithms for real-time effective processing of tactile interaction, such as if the huggable is petted or tickled. This information can then be shared with the behavior system to influence the response of the huggable. Finally, we are able to demonstrate the location of touch in real time on the virtual huggable for data visualization. This can also be viewed remotely via the website.